In this video we explain how to use fictitious faces, and in this application what we'll do is we want to make this cutout shown by the yellow line, this toolpath, and then we want to come in and drill horizontal holes in this edge, drilling to the left. On this inside edge we want to drill horizontal holes. So the only way we can do that is with a fictitious face. So we're going to define a new plane or a new face along this edge. So to do that we have to define 3 points along this plane, and we need to know the x and y coordinates. So we can see that the x coordinate of the line is 100, and it begins at y 113 and it ends at y 661. So let's go into the fictitious faces and let's define that plane. Let's take face number 7, we'll turn it on, we'll give the plane a name, we'll call it left side. You can call it most anything you want. And z plus minus, we'll come back to this checkbox in a minute. First step is we need to define the 3 points, and they're called P0, P1, and P2. And we have to define x, y, and z for each of those coordinates. So let's start off with the x point, P0. It's going to be x of 100. And these are absolute coordinates based on the entire part. So the y coordinate, let's start with 113, and the z point of this coordinate is 0, or the bottom of the part. Now with a fictitious face, the z coordinate is a little different than when you're programming a part. Typically the top of the part is 0 and z is negative into the part. With a fictitious face, 0 is the bottom of the part and z is positive up. So z0 defines the bottom of the part. So let's go on to P1, the second point. It's still 100 in x. This time the z or the y coordinate is 661, and we're going to stay on the bottom edge of the part, still 0 in z. And we go to P2, still 100 in x. P2, let's go back to 113 in y, and this time we're going to define the top edge of the part, and that's the part thickness, or we can just define that parametrically with the variable s, positive s. Okay, so this defines our plane. You can see this blue line indicates, or the blue rectangle indicates the plane. Now this red line indicates from which is the points to the working edge of the face. I mean, technically we could work this plane from either side, but this is defined by this z plus and minus, which we said we'd come back to. So if you toggle the z plus and minus on and off, it changes the edge of the plane from which you want to work. But it's critical to get this correct. But the red line is always indicated from which edge the tool approaches. So we want to approach from this edge indicated by the red line and drill into this face. If we click the Z plus on, then we would try to drill from this edge, which in this application we don't want. So just be very careful with the Z plus and minus and make sure that you define the plane correctly. So we hit OK, and now we now have a new face that we can view. And if you don't have it turned on, you can turn on the face view. Is much easier to view a fictitious face than trying to use the 3D view. You can't see a fictitious face at all in the general view. You can see it in the 3D view, but it's easier to see head-on inside the face view. As you can see here, we can click on our new fictitious face left side, and we see that face head-on, and it's also defined and highlighted in blue here. And if you don't have that turned on, the face view turned on, just go into Options, Editor Configuration, and with the high-level password, click on Single Face View here, and that'll give you access to this face view window. So we come in and we pick the face that we want to program, and now, like any other horizontal face in evolution, we reestablish X is always left to right on the screen, Y is up and down, and Z is penetration into the face. So if we were to drill a hole into this, go to our drilling command, and if we want a hole that's 100 millimeters from the origin of this face, and we want it in the middle of the edge, we would just say height of the face divided by 2. And if we want a 20 millimeter hole, then we define it. And we do have to use tool number and not diameter.